National Smile Day. It's nice to see everyone's beautiful smiles today in class. We're going to be looking at using your calculator and doing trig functions and looking at doing inverse trig functions as well today. And also converting between degrees and minutes and degrees. So you're going to need your calculator and a couple of main points up in front. One is make sure that you do not use your calculator right away. You want to solve the problem completely. At the very end, you use your calculator and make sure you don't round until the very last step. In this class, we're going to be rounding to the nearest hundredths place. The book is going to be different. They're going to be looking at significant digits. But in this, what I'm going to do is the nearest hundredths, and that's what I think the AP test is the nearest thousandths. But in this class, we'll just do the nearest hundredths. I think the main method is do not round until you get to the very last step. Let's go and first of all note that there are 60 minutes in 1 degree. We've dealt with degrees 0 to 360, and we're going to say within 1 degree there are 60 minutes. It's kind of the same concept as in 1 minute on the clock in time it's worth 60 seconds. Same idea. With 60 minutes, with 1 degree, it's worth 60 minutes. We'll show you how to convert that in a little bit. First thing that I'd like you to do is grab your graphing calculators, and I just want to make sure that you're in the right mode. Everyone should go into the mode button, check and see that you have degree mode and not radian mode. And then go ahead and calculate the sine of 42.2. And you could also find the cosine of 90 minus 42.2. And all of those answers should be 0.6717 approximately. That will reiterate the point that we made last couple lessons, and that is that the trig function of an angle is equal to the cofunction of the complement of the angle. And that's the same thing that we're doing with these two. All right. When we get to a problem like the secant of 42.2 degrees, I want to go ahead and use reciprocal identity first, and then I want to evaluate with my calculator. So I'm going to use the reciprocal identity to state that secant 42.2 is the same thing as 1 over the cosine of 42.2. And then at this point, I'm going to grab my calculator. And when you grab your calculator and type in 1 divided by cosine 42.2, should be able to come up with 1.35. Okay, so the secant of an angle is approximately equal to 1.35, which is a number. Whenever you take the trig function of an angle, you're always getting the number. Let's take a look at the next one. I have the sine of 35 degrees and 10 minutes. Now, be careful, because in your calculator, you can't just plug in 35.10 or 35.10, because your calculator is going to read degrees only with the trig function. So you have to convert the 10 minutes to degrees, and then the calculator will understand that you're only talking degrees and compute what it needs to. So to help you with this, what I'd like to do is write down the sine of 35 degrees, that's fine, but I want to change the 10 minutes to degrees. And we know that there are 60 minutes in a degree. And so you can do this one of two ways. And I'll show you both ways, and then you just pick the way that you're more comfortable with. The first way, which is more efficient, is where you start with 10 minutes, and you're just going to say that I want to convert to degrees. Well, I know there's 1 degree in 60 minutes. This is the same sign as the slash mark. That's minutes, and that's minutes. Just different ways of seeing it. And so when you do that, you're going to see that you're actually going to cancel your labels there on the minutes, and you're going to be left with degrees. So therefore, what you're going to see is it's just going to be 10 divided by 60 degrees. That's one way that you can think about it. The second way that you can think about it is to do a proportion, where it be degrees over minutes equals degrees over minutes. And so that degrees over minutes is going to be, let's see, you want to find out the number of degrees, so I'm just going to say that degree d over the minutes that you know, which is 10, is equal to the degrees 1 over the minutes 60. Degrees over minutes equals degrees over minutes, cross multiply, and solve, and you're going to get d is equal to 10 over 60. So either way, the top way is easier. The bottom way may make more sense to you, but one way or another, stick with it, and now you can convert. So back to this problem 44, the question is, what's the sine of 35 degrees, 10 minutes? I want to convert the 10 minutes, so what I can do is just say plus 10 divided by 60, and plug that whole thing into my calculator and let the calculator figure that out at the same time. So on your calculators, you just put in sine 35 plus 10 divided by 60. If I were to do that on the calculator, I would check my mode, go into the mode button. I am in degree mode, so that's fine. I then type in sine 35 plus 10 divided by 60, which is already on there, hit enter, and then ends up being 0.58, so approximately 0.58. Next thing what I want to do is calculate the table that you calculated yesterday and this on your calculator. And we're going to get approximate values, not exact values. Exact values are in terms of like pi and radicals. What we're going to do is use decimals and give approximation. So what I want to do is create a table with sine, cosine, and tangent, and 0, 30, 45, 60, and 90 on my graphing calculator. And so what I'm going to do is go to the y equals on your graphing calculator, and I'm going to plug in the sine x, the cosine x, and the tangent x. And I'm going to remember that in y sub 1 it's the sine x, y sub 2 cosine x, y sub 3 tangent x. Because I want to create a table, I want to go to the table setup and make sure that my commands are correct. Second table set. On the independent variable, the theta or the x variable, I want to do the ask function because when I put it in ask, I can type in whatever angles I want. That's good. So what I want to do is now go to the table, and whatever values you have in these fields, you're going to type in 0, 30, 45, 60, 90, and it'll overwrite whatever's in those rows. And when you do that, you're going to see that, for example, the sine of 0 is under y sub 1, that's 0. The cosine of 0 is 1. The tangent of 0 is 0. And you can see this is the table that we created, however these are approximates. An easy way to develop that same table without using the radicals. Next, I want to talk about the inverse function business and the regular function. Remember that you have what a function is. A function has a one-to-one ratio or one-to-one correspondence of x's and y's. Each x has to have only exactly one y. If it had two y's or more than one y, it would not be a function, it would be more of a relation. So a function is a specific type of relation, and it's one-to-one. Both of these, the trig functions that we've been dealing with, and now the inverse trig functions that we're dealing with have one-to-one ratios. Each x has exactly one y. Well, that's fine. How do we change the equation from the trig function form to the inverse trig function form? And this should go on your big rock sheet. This is the main idea. Students reach a stumbling block sometimes when they're going from one form to the next. This right here is the key in solving between those two forms. Notice what this says. It says that the trig function of an angle, like theta, is equal to a number. This is shorthand. But the trig function of an angle is equal to a number. And then if you use the inverse trig function, it's saying the inverse trig function of the number is equal to the angle. Notice how you're switching the angles places and the number places around, and you're adding an inverse to the trig function below it. I want to make kind of a big deal out of this because if you learn it, it's really easy to work with. But there's a lot of struggling involved with this, and that's why it's important to see what happens up front. If I were to take these two equations, sine of 30 equals 1/2. We learned that yesterday. And therefore, the sine inverse of 1/2 is equal to 30. Notice you're using an inverse function, you're replacing the number and the degree. Interesting enough, what you're really doing on inverse functions is you're switching the domain and ranges around. Your x's become the y's and the y's become the x's. If I were to write this out, where I write the sine of 30, which is a degree, so I'm just going to say sine of a degree is equal to a number notice what happens. Sine inverse, and be careful, this -1 is not an exponent. I know it looks like it is because you've always dealt with negative exponents like that, but this is shorthand in saying I'm identifying that as an inverse function. That's what the -1 stands for. So inverse function of sine, and then the number comes here, and that's equal to a degree. Whenever wherever you use inverse functions, you're getting a degree as a result. So notice how those things switch spots and you're using the inverse. So if you're ever figuring out what is the angle, I'm missing an angle, you've got to think, oh, I've got to go to the inverse functions. My suggestion is always set it up with the first step and then switch it around for the second step. Show your work. Constant theme in here. All right. And if you show your work, what happens is you do well on tests and quizzes, and then we get more smiley faces. Let's go to this tangent theta, example number 9. So this last one is where we don't have just a regular trig function. Well, that one is a regular trig function. The next example is that it's not. So we're dealing with a friendly still. I want to figure out what the theta is. Because of theta, I need inverse trig function. I need to switch it around. Tangent inverse 3.152 equals whatever my angle is going to be. As I type that in my calculator, it's pretty straightforward, and you'll see that you're going to end up with 72.26 degrees. And that's approximately. Not so hard. For some reason on the next problem, that's where students have troubles. Because it requires a couple more steps. Again, one step at a time, and then you get your answer. Secant B equals 1.0768. Solve for B, which is an angle. I can't just switch it around at the beginning because I don't have a secant inverse button. I have to go through, change it to cosine, solve for cosine, and then do the inverse after that. So it requires some steps here. First step is going to be convert it to cosines using the reciprocal identity, which we should know automatically now. Then what I want to do is cross multiply to solve for B. So it becomes 1.0768. I'm solving for the cosine B. Now, if you're thinking that you're too smart to have to go through all this work, you're not too smart to go through this work. There isn't anybody in the classroom that's too smart to go through all these steps. You have to go through the steps to foolproof any mistakes. At this point, we notice I want to solve for B. I do the flipping, and I turned it into the inverse function. And then at this point, you would plug it in your calculator, and you end up with 21.77 approximately. Degrees. Just want to make a quick point here that you could shorten up these steps, and some of you will make sense and you'll do it at this point forward. But if I recognize that the cosine B is on the bottom here, I could raise each side to the -1 power, and that would flip both sides. And so that would get you to this third step from here to here by raising each one to the -1 power. So if you raise both sides to the -1 power, it's doing the reciprocal of both of those sides, and you could go from here to here. But I caution you and caution you time and time again, do not do this in your heads. Do it step by step. Well, that concludes the class. Just remember, there are less muscles to create a smile than a frown, and smiles are contagious. So if you can go and do that, that'd be good. Yeah, Friday.